Hey guys, welcome to Chill Code. This is Jagdish over here. And in today's video, let's learn about what a linear regression model in machine learning is. So let's start with the definition. Linear regression is a statistical method used to model the relationship between a dependent and independent variables, allowing for the prediction of a continuous value based on input features. So let's not initially think about dependent and independent variables for now, but let's understand that there are two kinds of variables in between which we are trying to form a relationship. Once the relationship is formed, we are using it to predict a continuous value. So linear regression draws a best possible straight line through a set of data points to make future predictions. So if you see observe this graph, there are few data points over here. If you see, all these into points are the data points. The model is analyzing these data points and drawing a best fit lines which reduces the errors. Now what is an error? So error is nothing but, if you see, when x value is 3, so we have a real value as something in between 0.8. So this is the input which we gave to the model, but the model predicted a best fit line which says the value of y when x is 3 is something here, somewhere around 2.5 or something as such. So this is considered as an error of the model. We will calculate all the errors of each data points. The model builds a relationship and it gives an output of best fit line. Now, what are these x values and what are these y values? So, x values are nothing but the inputs which we are going to give it for a model, and y is an output which model gives us. See all the terms which we have used with an example right now. So, consider this example data set of house price prediction. So, here we have two columns. One is for square feet and another one is the price of the house in that square feet. If you see, if the square feet is 800, then the price is 15 lakhs, and if it is square feet is 950, the price is 18 lakhs, and so on. So the data set here is having 7 rows. Now let's figure it out which is independent variable and which is dependent variable. The name itself says dependent variable is dependent on another variable. In this data set, if you observe, the price of the house is dependent on the square feet. Okay, so once the square feet is increasing, we can say the price is also increasing. Price over here is a dependent variable and square feet over here is an independent variable because square feet is not dependent on any other variable. So the linear regression model is nothing but building the relationship between these two variables. Okay, and in this data set, the input is square feet and the output is price. So for example, the dataset says if input is 800, then the output price should be 15 lakhs. If input is 950, then the output price should be 18 lakhs. So these both are the inputs and outputs of this algorithm. So this input variable, which is square feet, is also called as features. A dataset can also have one or more features, which we will see in our future slides of this. Okay, and here you can observe we have divided something as test set and training set. So any data set we get, we will divide a part of it as training data and a part of it as a testing data. So ideally we take it as 70-30 ratio or 80-20 ratio, 80 giving to training and 20 giving to test data set. So the agenda over dividing the entire data set into training and test is that we train our model only with our training data set and we use our test data set to test the model's output. For example, in this data set, we are having 7 rows. So we are giving 5 rows for training set. So the model uses this 5 data sets and it tries to build a relationship with its output. Once a relationship is formed, then we use other 3 data sets over here, other 3 rows over here to find the output, and we will match whether these outputs are matching or not. We'll see more on this soon. And we always assume there is a linear relationship in this data set. So linear regression model works on a data set which has a linear relationship among itself. So now let's briefly see how linear regression works internally. Initially, we will pass the training set to our algorithm. In this case, our algorithm is linear regression algorithm, and it analyzes the values which we provide. So what we are providing as a training set is an input and an output. We are sending it a feature and an output. It will analyze the relationship in between this, and it gives a function as an output. So we call that function as hypothesis. Once the hypothesis is ready, the model is ready to take an unseen input, and it will try to predict the outputs. So if you see on the right hand side, we can consider this green line as an hypothesis. And based on these points over here, it has analyzed these points, and it found a best fit line, and we call it as a hypothesis. Now if we give another input as a test, it will give an output based on this line. So this part will be given as an output. What this hypothesis is, sometimes we may know what a hypothesis consists of, and sometimes we cannot know. But for linear regression, hypothesis is nothing but a straight line. Equation of straight line is nothing but ax plus b equal to y. In machine learning terms, we slightly modify these values and we consider it as theta 0 plus theta 1 of x, which is a straight line equation. So here theta 1 is nothing but our slope, and theta 0 is nothing but the y-intercept, because the output, because the hypothesis is a straight line, we are considering this equation could be our hypothesis. Now let's see briefly on types of linear regressions. So the first type is simple linear regression. So the example which we have taken is a simple linear regression. We call it as simple linear regression because it has only one feature. In the dataset which you have taken, square feet is an input or square feet is a feature, and the output is price. So there is something called as multiple linear regression. So in multiple linear regression, we have one or more features and only one output. If you see the same example, we have slightly modified, which is square feet and number of bedrooms. Now both of these are considered as independent variables which are helping to predict the value of price. Here, not only based on square feet but also based on number of bedrooms, the price is being calculated. If you see here, we are having multiple features, and the straight line equation will also change. In simple linear regression, the straight line equation is theta 0 plus theta 1 of x. But here, since we have two features, we consider this as x1, we consider this as x2, we consider this as an output y. This is a straight line considering of two independent variables. So we write the equation as theta 0 plus theta 1 x1 plus theta 2 x2. Okay, so now we are saying theta 1, theta 0, theta 2, and it goes till n, because the number of theta we use is depending on the data set, is depending on the number of features we are having. Multiple times we are using theta 0, theta 1, theta 2 till theta n. So how many features we are having, that many thetas we are using. That is what we have seen in multiple linear regression. If you see this equation a little bit clearly, we have 5 different values over here. So one is theta 0, one is theta 1, and one is theta 2. Okay, and we are having two more values, one is x1 and one is x2. So we have already seen what x1 and x2 is. The x1 and x2 in this case is square feet and number of bedrooms. Okay, now what about theta 1? What about theta 2? And what about theta 0? Multiple places we are saying theta 0, theta 1, theta 2. So how to choose these theta values? Let's see that. We can try with multiple values and choose the best one for theta. Okay, so we are going to do in multiple iterations. That's how we are going to find the theta values, because the first attempt we may or may not find the best theta values. Let's consider this simple equation theta 1x plus theta 0 as an example and see how it works. Initially, it is considering some values of theta, and we are getting some graph, which is this, and this is our hypothesis. Okay, we see this line is not best fit line. We can visually see that, and because it's not a best fit line, the values of theta are changed and again learned. This will be the second value. So we can see this is also not a best fit line, and the values of thetas are again changed, and then third time the third theta values seems to give a best fit line. So like this, until we get the best theta value, the model will keep on iterating and change the theta values. Now we got a best fit line after multiple iterations of theta values. We are considering this as best fit line on what basis? How we are going to know which is the best fit line? There should be some parameters by which we say this as a best fit line. So that parameter is nothing but our cost function. For every theta values which we have taken, which we have considered, the cost function will be calculated. And for whichever theta value the cost function is least, we consider that as a best fit line. So let's discuss more on cost function and how it works in our next video. Thanks for watching. That's all for today's video. I hope you have understood what a linear regression model looks like. If you're having any queries, please feel free to post them on comment section.